Hello, welcome to the second video in our continuing series on virtual mathematics class with Mr. Michael Izanata. I want to believe that you have seen the part 1 of this video, and if you have not done that, I would implore you at this moment to pause this video and click on the description of the video. You will see the link of part 1 of the video attached. You can then go ahead and watch it. That'll bring you up to speed, after which you can then come back and continue with this video. Okay, well, I bring you good news. In the last video I made mention of a restriction I had on my account, my YouTube account. After much trial, I was able to get the account verified by Google, and what that means is that I can now upload lengthier videos. Don't despair, because I won't bore you with long videos. I will always try to make it as short as possible. Okay, well, still speaking about YouTube, let me give you one did you know about YouTube. Did you know that YouTube was created in the year 2005 by three friends or co-workers, I should say. They were co-workers at PayPal, and PayPal, if you must know, is an online payment platform. It's one of the leading platforms in the world today for processing the payments online. So they came together, and then they hosted the site on Valentine's Day 2005. That was February 14, coming 9 days after my own birthday. So work it out. All right, and eventually they sold YouTube after a year and 9 months of its creation. They sold it to Google Corporation, as a Google, for a sum of 1.65 billion US dollars. And if you want to know the equivalence of that in today's exchange rate, that's somewhere around over 500 billion naira. You can imagine selling a website for that amount. Well, that's the power of tech knowledge, power of tech tools. So let's clap for YouTube and Google. Okay, that was in a lighter mood. Now back to business of the day. In the last video, we looked at the main of definite integrals. We struck the basic difference between a definite integral and an indefinite integral. We also looked at basic integration principles. So we're going to run with that this moment. So I have on the board displayed two problems that we intend to cover in this class, after which I will also show you the assignment that I've also included for you to test your knowledge. So we're going to solve them, but before we get into solving them, I want to give you kind of a formula for solving definite integrals. Now you would recall that your integration is also known as antiderivative. Your differentiation is derivative, while the integration is known as the anti-derivative, if you will. Okay, so what integration does is that it tries to rework what has been done by integration. So given a function, when you differentiate it, it has been taken a step further. Now integration will bring it back to the original function, okay, f. In other words, it means that if we want to represent that mathematically, it means that the integral of a function x, okay, with limits, upper limit of b and a, they can assume any value for a function x with respect to x, the integral of this function is equal to, when you integrate your x, you get the original function that was differentiated, so that will give you the function f. Then function f, you have to substitute the value of the upper limit in the given function that you have integrated, minus also in that same function you also substitute the value of the lower limit, which is your a. So this expression on the board being displayed now is the formula for your definite integral, that when you have a given function to integrate, what you want to do is you integrate the function inside a bracket, then after you are through with integration, then you go ahead and substitute the upper boundary, the upper limit for your x in the whole of the given your gotten expression. Then after that, you also substitute the lower limit in the same function, and then you subtract the values, simplify. The answer you get is the answer you're looking for. All right, so working with it, let's quickly look at example 1. Okay, so I am going to work with the knowledge that you all have seen the um, the first video to bring you up to speed with your basic integration. So we have question 1 to integrate a definite integral with upper bound of 3 and lower bound of 2. In the bracket you have 4x raised to the power 3 plus 6x squared plus 4x bracket close, then with respect to x. So what we want to do is first of all to get the function that was differentiated to get 4x raised to the power 3 plus 6x squared plus 4x. So we have to integrate that function first in the bracket, and by your integration we're going to integrate them one after the other. The three terms that we have inside the bracket, we're going to integrate them one after the other. So working with 4x raised to the power 3, remember our integration, we'll have to write our 4x. So we're having our 4x written, then the power of x is 3. So what do? We add 1 to the power 3 plus 1, that's 4. So the power changes to 4, and we use the 4 to divide, plus we go back to the next one. The next one we have 6x, so write our 6x back. What's the power of x? The power of x is 2, so we add 1 to 2. 2 plus 1 will give us 3, so the power changes to 3, and then we'll still divide by 3, plus we have the next one, which is 4x, which we are going to write. And then what's the power of x? The power of x, as you know, is 1, so 1 plus 1 is 2. We'll write 2 and then divide by that same 2. Now in this case you don't need to add a c plus c as I stated in the earlier video, but however you need to add something. So I'm going to go ahead and draw a line here. Now this line will be like a placeholder for our upper bound and our lower bound, the boundary conditions. So up here I'm going to write the 3. No, that didn't work out fine. Okay. I think this, well, that's 3. Okay, and then for the lower, let me try again. Okay, that's better. So then for the lower bound we have a 2. Okay, so the line is a placeholder for the boundary conditions, your upper bound of 3 and lower bound of 2. Okay, so we go further. Now looking at the expression on the displayed, you can see that we can further simplify. So the 4 cancels the 4, and what we have we have x raised to the power 4 plus the 3 cancels the 6, and you have a 2 there. So what we have there is 2x raised to the power 3 now, plus 2 cancels 4, we have a 2 there. So what we have now is 2x raised to the power 2. Remember, you still have to draw your boundary conditions. You still have to draw your boundary condition. Okay, so we have um, so draw our line now, and then we'll write our still upper bound of 3, and then the lower one for 2. Okay, just do bear with the scribbling, just make sure you follow along carefully. Alright, now having integrated, so we have gotten the function. Now what we have to do, so this expression x raised to the power 4 plus 2x raised to the power 3 plus 2x squared, that is our f. So what we have to do is to go ahead and substitute, just like this equation here says that when you get your f, you go ahead and substitute the values of your b into the f, minus you put the value of a into the function. So go ahead and do that. Remember, our b in this case becomes 3 and our a is 2. So let's go ahead and do that. So in this expression, we're going to substitute the value of x to be 3. So this changes to give us, instead of writing x now raised to the power 4, we're going to write 3. So we have a 3 raised to the power 4 plus we have a 2. Now instead of writing x, we open a bracket, and x is still 3, so that's now 3 raised to power 3 plus we have a 2, then open our bracket, and x is still 3, bracket close, raised to power 2 minus, so we have, what we have done just now is we have substituted the value of b in our function, b for 3. Now we'll go ahead and also substitute the value of a to be 2 in the same expression, x raised to power 4 plus 2 x raised to power 3 plus 2x squared. And when we do that, our x in this case changes and becomes 2. So we're having 2, we have a 2 raised to power 4 plus, we still have our 2. Now our x, as you know, is 2. We're working with the lower limit, 2 raised to power 3 plus we have a 2, and in the bracket we have a 2 still raised to power 2. Okay, so far so good. So what we have to do next is to simplify the given expressions. Okay, don't get confused. Let me draw a line for each stage and try and draw a line to demarcate that. Okay, so down to the next stage now. So down to the next stage, what we need to do is simplify what we have in the lines I've drawn. So 3 raised to power 4, with calculation 3 times 3, 9, 9 times 3, 27, 7 times 3, and that will give us 81. So we have 81, we have 81 plus, for the next one, 3 raised to power 3, that's 3 times 3, 9 times 3, 27, 27 times 2, that gives us 54. So we have 54 plus 3 raised to power 2, that's 9, 9 times 2, that gives us 18. So we have 18 for that, minus, we also try to simplify the one below, 2 raised to power 4, that's 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. So we're having a 16 plus 2 raised to power 3, 2 times 2, 4, 4 times 2, 8, so that's 8, and then 8 times 2, that also give us 16 as well, plus the next one, 2 raised to power 2, that's 4, 4 times 2, 8, so we're having an 8. Now simplifying all this together, 81 plus 54, that'll give us 153, 135, and 135 plus 18 will give us 153. So this one here simplifies to give us 153 minus, then when we simplify this one here, 16 plus 16, that's 32, plus 8, that will give us 40, and when you subtract the following, 153 minus 40, that will give us 113 units, and this is the definite integral. This is the answer that we are looking for, which can also serve as area under the given curve. So this question might come as in the same way as saying calculate area under the given curve in the following, then you see this question that you have here. So this is also how we solve that. When you're able to solve for a definite integral, you're also solving for area under the curve. Maybe when we look at areas under a curve, I might want to make some notes, some things with regards to that. Okay, so I just hope you can make sure you pause the video and take it slowly as you can, as you want, and then try to understand what we are doing. Okay, let's quickly also look at the second example before I call it a day. Now the second example, what we have there is that we have to integrate 3x raised to power 2 plus 2x plus 5 as a definite integral with upper bounds of 3 and lower bound of 1. Okay, so let me at this time clean off all this one. Remember that you can pause the video. And then make notes. Okay, so that's I'm a bit of taking a long time, so that when you want to pause, it will be easy for you to do that. Okay, so let me clean off the ones that we've solved. Okay, I'm cleaning our whiteboard now. Okay, so technology and innovation. So okay, almost done with that. All right, so we're back. So let's look at our second and final example. Okay, now for number 2, now I'm writing 2. For the second example, we are also going to get our f. Our f is the integration of what we have inside the bracket, so we're going to apply our integration rule. So for our 3x squared, remember we're going to write our 3 as well, 3x. Now what's the power of x? The power of x is 2, so 2 plus 1 give us a 3, and we go ahead and divide by that 3, plus we write our 2x. What's the power of x? It is 1. 1 plus 1 gives us 2, so the power changes to 2, and we divide by 2. Then plus, now we have this one, 5 is a constant, and in our part 1 of the video we say that when we integrate a constant with respect to a variable, it will take on the value of that variable. So in this case x, so 5 integrated with respect to x will give us 5x, and no need for adding plus c, but we do have to draw a line and write our boundary conditions, which in this case is we have 3 and then we have 1. Okay, so having done that, the next thing you want to do is to go ahead and substitute the values of your boundaries in turn in the given expression. So you're going to replace your x with 3 in the whole of the expression, and then 1. But before we do that, you can see that we can still simplify further. So let's simplify the expression further. This 3 cancels this 3, and then we have x raised to the power 3 plus the 2 cancels 2, we have x raised to the power 2. 5x has nothing to cancel out, so we say write our 5x back. Our boundary condition still remains 3 and 1. Then we can now go ahead and substitute the value. So substitute the value of x as a 3 in the given expression. So you have 3 raised to the power 3 plus 3 raised to the power 2 plus 5 into your 3 for x. Okay, we have eliminated, we are through with the upper boundary condition. Now of course minus, go over to the lower boundary condition, which is 1. So we're having a 1 raised by 3 plus another 1 raised by 2 plus 5 into 1. So go ahead and simplify. 3 raised by 3, that's 27. So we have 27, okay, plus 3 raised by 2, that's 9, then plus 5 times 3, that's 15. Okay, and minus sign. Then for the one below, 1 raised by 3, or for 1 raised to n power, will still give you 1, plus 1 raised by 2, that will still give you 1, plus 5 times 1, that will still give you 5. So adding them all up, 27 plus 9, that's 36, and 36 plus 15 now, that'll give us 51. So we're having this one here being completely simplified to give us 51 minus, then 1 plus 1, 2, 2 plus 5, that's 7. So we have 51 minus 7, and that will give us 44, which is the answer that we are looking for. So 44 is the answer for question 2. Whew. Can you imagine how simple that is? Okay, so that's how we solve definite integrals. In the next video, we'll look at solving for definite integrals of trigger values. Yes, there are some special trigger like your sine, cosine, and all that. We want to see, we want to look at how we solve for the definite integrals. Okay, so make sure you go over the video and then internalize what we're doing. Okay, and if there's any need for clarification, you're free to reach out to me, and then take it up from there. Before I leave you, I already have an assignment prepared for you, so I'll just scroll down to where I have the assignment for you to. Okay, so this is the assignment here. Okay, so let me read it out in case you're not sure what I wrote. Evaluate the following definite integrals. You have A. You have to integrate a definite integral with upper bound of 2 and lower bound of 1. In the bracket, what you have there is 3x squared plus x plus 2. That's what you have there. Okay, just don't be afraid. You can do it. Same thing. Now, when you have a fraction, still don't despair. It's still the same. Your basic mathematics. For your b, you have a definite integral, upper bound of 3 and lower bound of 2. In bracket, you have 5x raised to the power 3 minus 2x squared plus 6x with respect to x. And for the last one, you have to integrate with the upper bound of 2 and lower bound of minus 2. Yes, you can have a negative value. Okay, so work that out. In the bracket, you have 4x raised to the power 3 minus 3x squared plus 2x minus 5 with respect to x. Okay, I'm just doing this just in case you are not sure of what I wrote. So if you look at the sound of my voice, I'm certain that you get what is displayed on the board. Okay, so I hope you guys have enjoyed the class so far. Yes, you can go ahead and find out more about Google and YouTube. So currently YouTube is owned by Google, and so many other subsidiaries that they also have acquired in recent times. But to the next class, just remain safe, do your homework and submit before the next class. I will see you in the next video. Bye.